Imagine waking up to a headline no one believed they would ever read. Deep beneath the mountains of Yellowstone National Park, one of Earth's largest volcanic systems has begun a massive eruption. Within minutes, a towering column of ash punches through the atmosphere, climbing more than 20 miles into the sky. Daylight fades into an eerie twilight as shockwaves ripple across the surrounding landscape. Highways disappear beneath falling ash. Airports across the western United States shut down almost immediately. Millions of people watch live broadcasts, trying to understand whether this is a local disaster or the beginning of a continental crisis. It is a scenario scientists consider extremely unlikely in our lifetime, but one that has fascinated researchers, emergency planners, and documentary filmmakers for decades because of its enormous potential consequences. The Yellowstone volcanic system has produced several colossal eruptions over the past 2 million years, each separated by vast stretches of geological time. Modern monitoring by scientists has found no evidence that such an eruption is imminent today. Thousands of small earthquakes, ground deformation, and geothermal activity are carefully tracked every year, and these are considered normal parts of Yellowstone's active volcanic system. However, for the purpose of this documentary, we will explore a carefully imagined worst-case scenario based on current scientific understanding. If an eruption of extraordinary magnitude did occur tomorrow, how would its effects spread across the United States? Which regions would face immediate danger, and which would have the greatest chance of remaining operational during the months that followed? The first hours would be defined by geography. States surrounding Yellowstone would face devastating volcanic ash, pyroclastic flows near the eruption zone, and widespread infrastructure collapse. Farther away, the greatest threat would not necessarily be lava but microscopic volcanic ash carried by high-altitude winds. Fine ash can disable aircraft engines, contaminate drinking water, damage electrical equipment, destroy crops, and create severe respiratory hazards. Transportation networks would struggle to function as visibility declined and machinery failed. Hospitals would become overwhelmed while emergency agencies attempted to coordinate one of the largest disaster responses in modern history. Every state's level of risk would depend on its distance from Yellowstone, prevailing wind patterns, population density, critical infrastructure, and ability to adapt under extraordinary pressure. This documentary is not a prediction of the future. It is a scientific thought experiment built upon geological research, atmospheric modeling, emergency planning principles, and historical evidence from major volcanic eruptions around the world. Over the course of this journey, we will rank every one of America's 50 states from highest risk to lowest risk, examining how each could be affected if Yellowstone experienced an exceptionally rare supereruption. Some rankings may seem obvious, while others will challenge expectations. Distance alone will not determine survival. Climate, logistics, agriculture, energy, healthcare, and resilience will all play decisive roles. By the end, the map of the United States may look very different from the one we know today, revealing how interconnected every community truly is when nature operates on a scale beyond human control. The ranking begins where the danger is greatest. At the highest level of risk are Wyoming, Montana, and Idaho, the 3 states surrounding the Yellowstone volcanic system. In this hypothetical scenario, these regions experience the first and most destructive effects within minutes of the eruption. Communities closest to the caldera face extreme hazards from pyroclastic flows, superheated gases, volcanic bombs, and powerful earthquakes that accompany the collapse of the volcanic chamber. Entire valleys disappear beneath thick blankets of ash, while roads, bridges, communication towers, and power stations suffer catastrophic damage. Visibility falls to nearly zero as daylight is swallowed by a massive ash cloud stretching across the horizon. Emergency responders, despite years of planning and training, find themselves confronting conditions unlike anything in modern American history. Airports close almost instantly, helicopters struggle to fly through ash-filled skies, and evacuation routes become overwhelmed before many residents can escape. Although such an event is considered extraordinarily unlikely by scientists today, this imagined scenario demonstrates why proximity to Yellowstone would place these states at the greatest immediate risk. The next tier includes Utah, Colorado, North Dakota, South Dakota, Nebraska, and parts of Nevada. These states avoid the direct volcanic blast, but they face a different enemy carried by the atmosphere itself. Powerful upper-level winds transport billions of tons of microscopic volcanic ash hundreds and even thousands of miles from the eruption site. Unlike ordinary dust, volcanic ash is made of sharp fragments of rock and volcanic glass capable of damaging engines, contaminating water supplies, reducing visibility, and threatening human health. Major highways become increasingly hazardous as ash accumulates on roadways, while electrical substations and communication networks begin experiencing widespread failures. Agriculture suffers severe losses as crops are buried beneath ash deposits and livestock struggle to find clean food and water. Across these regions, daily life slows to a standstill as governments declare emergencies and critical resources are redirected toward rescue operations, healthcare, and infrastructure protection. Farther east, the level of danger gradually shifts from immediate destruction to long-term disruption. States across the Midwest, including Kansas, Iowa, Missouri, Minnesota, Wisconsin, Illinois, and Michigan, may escape the thickest ash deposits depending on prevailing winds, yet they remain deeply affected by nationwide supply chain failures and economic instability. Food distribution networks become strained as Western agriculture declines, fuel deliveries are interrupted, and transportation systems face unprecedented delays. Manufacturing centers experience shortages of essential materials, while hospitals prepare for respiratory illnesses caused by fine airborne ash drifting across large portions of the continent. Air travel remains heavily restricted as volcanic particles pose serious risks to jet engines, disrupting commerce and emergency logistics alike. Communities begin adapting to a new reality in which resilience, cooperation, and resource management become just as important as geographical distance from the eruption itself. Meanwhile, the eastern and southeastern United States, including states such as Florida, Georgia, the Carolinas, Virginia, New York, and much of New England, initially appear to be the safest regions. However, safety proves to be a relative term rather than an absolute one. These states become vital centers for emergency coordination, medical assistance, economic recovery, and the relocation of displaced populations arriving from harder-hit areas. Ports along the Atlantic coast remain essential for maintaining international trade, while military installations and major transportation hubs support nationwide relief efforts. Yet even these distant regions cannot escape the broader consequences of a disaster on this scale. Financial markets experience historic volatility, energy demands surge, and millions of Americans seek temporary shelter far from the volcanic ash. As the nation struggles to adapt, one question remains unanswered: among all 50 states, which will ultimately prove to be the most resilient when the immediate crisis gives way to the long road toward recovery? As the first weeks pass, the immediate shock of the eruption gives way to an even greater challenge: survival in a nation transformed by cascading failures. By now, scientists have completed detailed atmospheric models, allowing emergency officials to refine the risk rankings. States such as California, Oregon, and Washington avoid the catastrophic ash depths seen around Yellowstone, yet they face major disruptions from damaged transportation corridors, reduced air quality, and the loss of trade routes connecting the western interior. Along the Pacific coast, ports become lifelines for imported food, medical supplies, and industrial equipment arriving from overseas. Meanwhile, states farther south, including Arizona, New Mexico, and Texas, experience varying levels of ashfall depending on shifting wind patterns, but their greatest burden comes from supporting millions of displaced residents seeking shelter, employment, and medical care. Cities expand emergency housing programs while power grids and water systems operate under constant pressure. In this evolving crisis, resilience is measured not only by distance from the volcano, but by each state's capacity to sustain its population under extraordinary demands. Across the Gulf Coast and southeastern United States, another reality begins to emerge. States including Louisiana, Mississippi, Alabama, Georgia, and Florida remain largely outside the heaviest ash plume, allowing them to preserve functioning airports, seaports, and energy infrastructure. These regions quickly become the logistical backbone of the national recovery effort. Cargo ships unload emergency supplies around the clock, military transport aircraft operate continuous humanitarian missions, and hospitals receive patients evacuated from the hardest-hit western states. Yet this apparent advantage comes with enormous responsibility. Rapid population growth places intense strain on schools, housing, healthcare systems, and local governments. Temporary communities appear almost overnight as thousands of families search for stability. Emergency planners must balance compassion with limited resources, recognizing that even the safest states are vulnerable when millions depend on them for survival. Far to the northeast, states such as New York, Pennsylvania, Massachusetts, Vermont, New Hampshire, and Maine benefit from their considerable distance from Yellowstone and generally lighter ash exposure in this hypothetical scenario. Financial institutions, research laboratories, universities, and federal agencies collaborate to coordinate long-term recovery strategies while monitoring changing atmospheric conditions. Scientists continue analyzing volcanic activity using satellites, seismic networks, and climate models, searching for any indication that the eruption is weakening or entering another dangerous phase. International partners also become deeply involved, providing humanitarian aid, engineering expertise, and specialized equipment. The disaster is no longer viewed as an American emergency alone. It has become a global event with economic, environmental, and humanitarian consequences reaching far beyond the country's borders. Around the world, governments closely watch every new development, understanding that disruptions to the United States ripple through international trade, aviation, agriculture, and financial markets. After months of careful analysis, emergency officials finalize the nationwide ranking based on the combined effects of direct volcanic hazards, ashfall, infrastructure resilience, healthcare capacity, economic stability, and long-term sustainability. At the highest risk remain Wyoming, Montana, and Idaho, where proximity to Yellowstone leaves little opportunity to avoid catastrophic impacts. The middle of the ranking includes many western and central states that endure severe disruption but retain the ability to recover through coordinated national support. Toward the lower risk end are much of the Atlantic coast and portions of the southeast, where functioning infrastructure provides the strongest foundation for rebuilding. Yet the final lesson is impossible to ignore. No state truly escapes untouched. In an interconnected nation, survival depends not only on geography, but on preparation, scientific understanding, resilient infrastructure, and the willingness of millions of people to work together when confronted with one of nature's most extraordinary hypothetical events. In the months that follow, the towering ash cloud slowly begins to thin, revealing a nation forever changed. Recovery does not arrive with a single announcement or a dramatic turning point. Instead, it unfolds through countless acts of determination, scientific innovation, and human cooperation. Engineers work tirelessly to restore damaged infrastructure while researchers continue monitoring Yellowstone for signs of renewed activity. Farmers experiment with restoring ash-covered soil, transportation networks are gradually rebuilt, and communities separated by thousands of miles unite to support one another. Yet the scars remain visible. Entire landscapes have been reshaped, economies have been forced to adapt, and millions of lives have taken unexpected paths. Even in the states ranked among the safest, the consequences of such an extraordinary event continue to influence daily life. The disaster has become more than a geological crisis. it has become a defining chapter in American history, demonstrating how deeply connected every state truly is when confronted by forces beyond human control. As scientists review the lessons of this imagined catastrophe, one conclusion becomes unmistakably clear. Preparation saves lives long before a disaster ever begins. Modern monitoring systems, satellite observations, seismic networks, emergency planning, and international scientific collaboration remain humanity's strongest defenses against natural hazards. Yellowstone itself continues to be one of the most carefully studied volcanic systems on Earth, with experts constantly tracking earthquakes, ground movement, gas emissions, and geothermal activity. Importantly, there is no evidence that a catastrophic Yellowstone supereruption is expected in the foreseeable future. This documentary has explored a carefully constructed worst-case scenario designed to better understand risk, resilience, and emergency planning, not to predict an imminent event. By examining how such a crisis might unfold, we gain a greater appreciation for the remarkable scientific efforts that help protect millions of people every day. The final ranking of all 50 states tells only part of the story. Geography certainly influences risk, but resilience depends on far more than distance alone. Strong infrastructure, effective leadership, modern healthcare, reliable communication systems, emergency preparedness, and the willingness of communities to work together ultimately shape how societies recover from even the most severe disasters. Throughout history, humanity has faced earthquakes, hurricanes, volcanic eruptions, pandemics, and countless other challenges. Every generation has been tested by forces that seemed overwhelming in the moment, yet progress has always been driven by knowledge, cooperation, and innovation. The hypothetical Yellowstone eruption reminds us that while nature possesses extraordinary power, human resilience has repeatedly demonstrated an extraordinary capacity to adapt, rebuild, and move forward. As the sun rises once again over the mountains of Yellowstone, steam quietly drifts from the familiar geothermal landscape, reminding us that Earth's greatest forces often operate silently beneath our feet. The same volcanic system that inspires awe, attracts millions of visitors, and fuels groundbreaking scientific research also reminds us of our planet's dynamic history spanning millions of years. Whether viewed through the eyes of a geologist, an emergency planner, or an ordinary citizen, one truth remains timeless: understanding nature is far more powerful than fearing it. The story you have witnessed is not a forecast of tomorrow, but a reflection of why science, preparation, and curiosity matter. In the end, the greatest lesson is not about which state ranks safest or most dangerous. It is that knowledge, resilience, and unity remain humanity's strongest safeguards in the face of even the most extraordinary possibilities.